Okay, let's solve some exponential equations using the one-to-one property. So we're going to start over here. We're going to look at 16 raised to the x plus 3 equals 4 to the 4x plus 7. And so the first thing that I really want to try to do is to see if I can get these two exponentials to the same base. And if I look at this 16, well, 16 is the same as 4 squared. And if I express it that way, then I can take this left side and express this as 2 raised to 2 times x plus 3. And that set that equal to 4 equals the 4x plus 7. All right, well, now my bases are the same, so I can, in effect, just cancel those out. Now, distribute that 2 to the x plus 3, and that's going to give me 2x plus 6 equals 4x plus 7. And then we just go about solving this algebraically. So let's see, I'm going to subtract 2x from both sides and also subtract 7 from both sides. And when I do, that's going to give me minus 1 over here equals 2x. And now I can just divide by 2, divide 2 to both sides, and I get up that x equals 1/2. So we solve that exponential equation. X is equal to minus 1/2. Let's look at the next one here. All right, so we got 3 to the x power equals 3 to the 3x minus 4. So again, I want to see if I can get these to the same bases, and I can probably easily recognize that 9 is the same thing as 3 squared. So that's now 3 to the 2x equals 3 to the 3x minus 4. So again, I got my bases the same. I can cancel those. Now I'm left with 2x equals 3x minus 4. And let's see, I think I'll subtract 2x from both sides and add 4 to both sides. And so when I do all of that, I'm going to end up with 4 equals x. Okay, done. So 9 to the x equals 3 to the 3x minus 4. X is equal to 4. And I say that would be 9 to the 4th power. Let's just double check this. 9 to the 4th power times, let's erase and start over. So we got 9 to the 4th power equals 3. 3 times 4 minus 4. And so 9 to the 4th power equals 12 minus 4, 3 to the 8th power. So let's see, let's get the calculator out and see how that flies. So I've got 9 to the 4th power. That equals 6,561. And 3 to the 8th power equals 6,561. Done. Now let's look at a couple that might be just a little bit hairier. But we can still get these to the same base. That's our first goal. And again, we won't always be able to get them to the same base, but when we can, that's what we want to do. So let's start over here on this left side. I've got 1/4 raised to 2x minus 1 equals 1/8 raised to the 11 minus x. I've got 1/4 and 1/8. Well, I can re-express this 1/4 to being 1/2 raised squared. 1/2 squared is 1/4. So now I've got 2 times 2x minus 1. And over here on the right side, well, you can probably see I can express that 1/8 as 1/2 cubed. (11 minus x). Okay, so now I've got them to the same bases. I can now cancel the bases out. Let's go ahead and distribute that 2 to the 2x minus 1. That's going to give me 4x minus 1, minus 2, excuse me, minus 2. 4x minus 2 equals, and we'll distribute to 3, 33 minus 3x. All right, so let's combine our like terms. I'm going to add 3x to both sides. That's going to give me 7x over here. And I'm going to add 2x, the 2 to both sides. And that's going to give me 35. So I got 7x equals 35, or x equals 5. All right, we took that 1/4 and that 1/8. We made them common bases by expressing that as on the 1/4 of 1/2 squared, and the 1/8 as 1/2 cubed. Did our distribution, combined like terms, isolated the variable, solve for x. All right, now this next one's got a little bit of a different wrinkle to it. It's similar, but I've got 2/3 to the x minus 5 equals 9/4 raised to the power of 3x over 4. So I'm going to start again. Okay, what can we do here? I'm going to work on this 9/4 here. Let's see. It's 9/4. And I got 2/3 over there. Well, I could re-express this as 3 squared over 2 squared. In other words, 9/4 equals 3 squared over 2 squared, right? 9/4 is 9/4. Okay, but that still doesn't give me this 2/3 that I'm looking for, or 2/3 that I'm looking for over here. But what if I raised all of this? What if I raised this 9/4, which we've already agreed is the same as 3/2, 3 squared over 2 squared. But I did it to the negative. Or I could say that 3/2 raised to the minus 2 power. Now, if you remember, when we got a negative exponent, it just flips the number. And so that would actually make that, when I raise this to the minus 2 power, is actually going to make that 2/3. I should say this right here. Forget that. Minus, let's see, 2/3 raised to the minus 2. That would give me 9/4. Might ponder that for a moment. Okay. So we're going to re-express this. We got now the 2/3 raised to x minus 5 equals 2/3 raised to the power of minus 2 times 3x over 4. Okay, well, at least I can get my bases canceled. So now I've got x minus 5 equals, well, let's see, I can make that and reduce that to 2. That give me minus 1. So now I've got minus 3x over 2. Okay, so we're still trying to solve for x. Well, now I can multiply 2x minus 5 equals minus 3x. And let's take this up here. So now I've got 2x minus 10 equals minus 3x. So let's combine like terms. Well, let's see, I got minus 10. Subtract 2x from both sides gives me minus 5x. And divide both sides by minus 5, and I end up with 2 equals x. How about that? Might want to look at that one again.